Hello, everyone. So welcome to the I-SEAMORE webinar on AI operations in border management. Today, we are very glad to welcome the METEOR project, ODYSSEUS project, and BEG-INTEL project, our sister projects on this webinar that they will present a little bit more about themselves, the project itself, their missions, their goals, and how are they operating AI technologies in their own initiatives. Here you can have a quick overview of how this webinar will be organized. So we will have first and foremost our invited external speaker, Giulio Mancini. Giulio Mancini is from DG Home. He's our European Commission representative on this webinar. And Giulio will just basically tell us more about innovation policy in border management, and will particularly focus on the regulatory aspects relevant for artificial intelligence. Julio, if you want, you can just start sharing your screen and do a little bit of introduction for this webinar too.
Thank you very much, Laura. Just checking that you can see the presentation correctly.
Yes, it's perfect.
And you can hear and see me. So, wonderful.
Exactly.
Thank you very much, and a very good morning, everyone. And many thanks to I-SEAMORE and the other projects for organizing this webinar. I think this is very, very relevant, very interesting. I think it's reflected also by the successful turnout that you have on the participants. So very, very good morning, everyone. My name is Giulio Mancini. I'm from the Directorate General Migration and Home Affairs, or DG Home of the European Commission, and particularly in the unit managing the EU innovation policy for civil security and border management. We are the team planning and designing with member states and other colleagues in the EU, including agencies, the EU innovation policy on these aspects, and the funding on research and innovation on these aspects, including very proudly the funding to the 4 projects that organized these webinars. So thank you very much again. And as Laura was mentioning, I wanted to try to give a little bit of let's say background and context. Starting from the consideration that the 4 projects organizing the webinar and that will present the research work today, are in the framework of the EU Research and Innovation Program on Civil Security and Border Management, a program that is managed by DG Home with member states and is a part of the EU Framework Program for Research and Innovation since 2004. A specific part dedicated to civil security, civil protection, and border management research and innovation. It's the smallest part of the framework program for research and innovation of the European Union, but it's a very specific and very dedicated part. Since, in the last 20 years, the EU funded almost 4 billion euros to over 700, almost 800 research projects, each project being a multi-year, multi-million, excellent consortium of some of the best European universities, research organizations, industry, civil society, and very importantly, practitioners. Our program is special compared to other European research programs because it mandates the participation of users like border authorities, coast guards, police forces, civil protection authorities in the research consortium together with innovators. And it is particularly important for security because security is not a normal market industry. It's heavily demand-driven, it's heavily regulated, and rightly so. In Europe, is also kind of fragmented, so it really needs a capability-based, forward-looking innovation policy to make sure that European citizens and European practitioners have European solutions for the security and border management needs today and tomorrow. And this is key, fundamental also for the European strategic autonomy. in the current world and in the future. And indeed, many of the today's European security technologies and knowledge, if coming from European companies, have in many cases been developed also thanks to research and development co-funded by this program, and we're very proud of that. Of course, in this context, especially in recent years, but being research also not very recent years, artificial intelligence is very present, is very used, is very studied and exploited. And it shouldn't be a surprise. AI is now present in our lives in all sectors, and so also in security and border management. Just because when there are sectors where there is a lot of data, and now data is everywhere, today is approached using AI because it's more powerful, more efficient, more performing, etc. And some example of how AI is being studied and developed or have been in these sectors include, for example, doing big data analysis to fight drug trafficking or drug production or illegal trafficking of other crime-related circles. Or, for example, to model and do risk assessment of disasters and help civil protection to do that. Or using computer vision and data analysis to improve detection of threats, be explosives or drugs, or chemical or biological or radiological threats, or other illegal or illicit or dangerous items. Or to come to the examples of borders, improve the security of identity management and making sure that the passports or travel documents or biometric data of people are secure and identity thefts are mitigated. Or being able to improve border surveillance, being able to use, analyze, fuse quicker and better with helping the officers, those with human oversight, helping them using big data and analyzing those. So very important. And the four projects that we have today, they are, and we look forward to their examples. I assume each of them will say a bit more on where they come from, but they each come from a different topic of our research and innovation program, applied research and innovation program that we programmed between 2021 and 2022. And so they're relatively younger research projects coming from capability-based topics of the EU R&D for border management program of the last few years. But from our program, the EU Research and Innovation Program for Security and Border Management, we also support research and innovation in artificial intelligence for security and border management. So not just research aiming at a certain capability, which may and do in some cases use artificial intelligence tools, but also research on using artificial intelligence better and in a trustworthy manner in the future, also for security aspects. For example, project AP for AI, or Accountability Principles for AI for Law Enforcement, or the family of 3 projects, Aligner, Starlight, and Pop AI, funded with 20 million euros, a topic dedicated to good AI tools for law enforcement and countering the risks coming from bad exploitation, let's say, of artificial intelligence, which concluded a research project that concluded recently. And another aspects that the Commission and the EU supports on is on quality data and secure and trustworthy data for the training of artificial intelligence models for possible security applications, law enforcement, etc. Data for training is key for artificial intelligence, and experts who are more experts than me today may highlight that again, because the quality of data and the possibility to train AI models with good data determine the performance and the reliability and trustworthiness of AI models. So projects like Tessera and Lago are conducting preparatory work with the many stakeholders to understand what could be the requirement for good training data for artificial intelligence models in very important but also sensitive areas like security and border management. What could be requirements for interoperability? What could be requirements for a governance framework? Possibly moving towards a European security data space for innovation. So a data space that can be used by innovators and deployers to test, study, and assess possible artificial intelligence models needed in these sectors. A sector that at the EU level is also regulated, notably by the EU Artificial Intelligence Act or AI Act, the first specific regulation on AI in the world, which entered into force last year in 2024. The EU AI Act has an approach, a risk-based approach on regulating AI. With some categories of AI models, some applications, better said, of AI models where risks outweighs the benefits, and these are unacceptable risk for AI models, and other applications where benefits outweigh risks, but with some categories where still are deemed high risk. And so they come with additional requirements and safeguards, both for developers of AI models and deployers of AI models. And notably for our line of work, applications in, for example, law enforcement or border management are typically in the high risk category. So they can be and should be studied and developed and used when they allow to improve the performance and the tasks of users and the protection and the services to citizens and society, but they have to come with specific safeguards. Some examples may be some uses of biometrics for identifying people, some aspects of risk assessment to identify and protect victims of crime, for example. These and other applications, if they fall under the high-risk category of AI models, they have to come with some obligations for the providers, for example, to follow some trustworthy artificial intelligence requirement, some quality management systems to register the standalone artificial intelligence systems in dedicated EU databases, including secure sections for law enforcement, and for deployers, so users like authorities, to ensure human oversight of whatever process is helped by AI, to inform people that any process may be helped by AI still with human oversight, and so on and so forth. And especially on high-risk use cases, the Commission is required by the regulation to adopt guidelines on these classifications by early 2026. So please stay tuned for more specific regulations. The AI Act does not apply to research. Research is explicitly excluded by the AI Act. But what we always say to researchers working in applied R&D, like those in border management from our program, is that the recommendation to consider the potential application of AI further down the line if their research will lead to products. Because that's important, it's a particular responsibility in border management and law enforcement, and it's also a potential advantage for innovators to have a competitive advantage on embedding EU regulations and requirements in their products early on. To conclude, a couple of highlights on other initiatives that could be interesting for people to be aware and follow. Starting from the Community for Research and Innovation for Security, or CERIS, a network and community that DG Home manages and facilitates, organizing thematic workshops on innovation for security, civil protection and border management, publishing and preparing reports, and thematic report on research and innovation on these aspects in Europe. We invite you to check those out. The awareness on the work that we do with the EU agencies, including the colleagues at Frontex and Europol or EULISA, working operationally together with member states authorities in these aspects and working together among them and with us in the EU Innovation Hub for Internal Security, also a source of potential interest information. And lastly, an announcement and a reminder, some of you may already know, but in June, there will be the 2025 Security Research Event, a conference and exhibition organized by the Commission this year in Warsaw, with many EU-funded and European innovations and discussions on research and innovation for security and border management. You're all invited to attend. Registrations are open. And I'm sure that the slides will be and can be also circulated or made available. There are a bunch of extra links for more information if useful. And thank you very much and enjoy the rest of the webinar.
Thank you very much, Giulio, for your presentation. It was super interesting. You covered it all. You even presented briefly the participating projects of this webinar, so thank you for that. And I will jump right into the Intel project. For the Intel project, we have Georgios Bardes. He's the senior software engineer at net company Intrustov, and he's the technical scientific coordinator of the Big Intel project. With over a decade of experience in computer vision and convolutional neural networks, Georgios has contributed to numerous industrial applications and research initiatives. Georgios, the floor is yours. I hope Georgios is in the call. Well, while Georgios doesn't open his microphone and starts presenting, maybe we can just jump into the I-SEAMORE presentation. Instead of giving you here a brief introduction about I-SEAMORE project, we have Ricard Boudet, the project manager of the I-SEAMORE from Eviden. So Ricard, feel free to present it.
Thank you, Laura, for your words. So I'm going to share the presentation. I hope you can see the slides. Can you see the slides?
Yes.
Okay, thank you. Okay, so I'm going to provide an introduction to the project, I-SEAMORE, and also I will give some details about the AI, how AI is used in I-SEAMORE, what are the implementations, the applications that we are using. Okay, so basically, I-SEAMORE is a project from Horizon Europe, as Julie just said. It has a duration of 30 months, so supposedly to end in June this year, but let's say we are in the process of an amendment that will extend the project for 4 months. And currently 16 partners from 10 countries and a budget around 8 million euros. So basically the goal is to deliver a complete platform which is capable of managing the operation of multiple assets and systems, let's say with advanced maritime surveillance capabilities that can be easily deployed and operated at the European Maritime Operation Centers. For this purpose, it is using, in the specific case of I-SEAMORE testing, maritime surveillance with unmanned autonomous vehicles, aerial and water, also satellite data, artificial intelligence, and big data analysis. So regarding the partners, we'll say we have 3 big groups of partners, the industrial ones, from our side, Atos, Thales Netherlands, Excel, SIS Group, Primoco, Terracina, in Innovation, and F6S. Some of them are providing technology, some of them are providing, let's say, ethical and communication capabilities. Then we have a group of 4 end users, Portuguese Navy, then also the Romanian Coast Guard, the Spanish Tax Agency, the Custom Service from the Spanish Tax Agency, and the UK Border Force. And then we have also some research and technology organizations like INOF, TNO, Vortex, and I-SEAMORE. Okay, so about the objectives of the project, basically it tries to provide an enhanced cross-border and cross-sectoral cooperation through improved information sharing, also facilitating the interaction among a wide variety of stakeholders, including citizens and civil society. Also improve the integration environment, connecting heterogeneous assets and tools. Contribute also to elaboration of policy recommendations on maritime surveillance systems, provide reduced reaction and response times, and also to enhance the co-creation between end users. Implementation, well, basically it's based on 4 main pillars. The first one of them is the employing of, we will can see them now in details. The first one is the use of long endurance man assets. You can see here that we are using at this moment one USB provided by the company Excel, which is an unmanned surface asset with an endurance up to 80 hours and a payload with visible and infrared cameras, radar, and also some enhancements with PTZ air payload for night operation and processing of data. Then we have the Primoco 150, which is a medium altitude aerial unmanned asset with an endurance of to 15 hours to 100 kilometers range. And as with payload, it can, let's say, can have a head of observation, infrared cameras, laser rangefinder, multi-directional scanner. In this case, specific case, there have been some enhancements to the UAV. There has been a more efficient power system in the course of the project. It has been enhanced, and also the navigation using EGNOS. And also, it has been, let's say, provided with a radio frequency SIGINT payload, which is provided by another partner from the consortium, enough. In addition to those two UXVs, we have also, in the course of the current amendment, going to incorporate a third one, which is a UAV from the Portuguese Navy, which is, let's say, the main end user of the project. Okay, about pillar 2, which is heterogeneous data. Basically, the main source of satellite data for the project is coming from Copernicus program, from the Sentinel-1 for health observation. We have also access to Sentinel-2 and Sentinel-3 through Copernicus Data Spaces ecosystem. Okay, the third pillar is the artificial intelligence and big data analysis. So in this case, I-SEAMORE deals with novel algorithms and data analysis techniques that enable capabilities such as detection of and tracking of objects, automated track classification, early detection of anomalies, and threat risk analysis. So specifically for visual analytics, we provide enhanced object detection capabilities to the C4I platform with a focus on ships, allowing the mission commander and other operational staff to extract enhanced information about the detected vessels, like vessel type, size, plate number, number of people which are on the ship. Both capabilities also with daylight and infrared. And then we have the other big group of, let's say, AI-like technologies, which is data fusion of heterogeneous data. This collects all types of information coming to the C4A, which is Earth observation, infrared, data, radar tracks, ACE, and all the detections that have been mentioned previously with visual analytics. And then it translates this into actionable information for end users. So here as an example, we have the data fusion to detect abnormal behaviors. I said before, different data sources are fed into the system with relevant data, and then we have radar, cameras, AI, satellites, sensors that provide different views of the situation. But often the sensors do not provide actionable information. You see the situation, the current situation at the moment, but you have the intelligence to detect what is really happening. So all this information is turned into actionable information by the analysis of complex correlations with some models and algorithms, and then it provide informed decision making for example, in the case of the drug smuggling use case. So imagine, for example, there is a commercial ship which is following a shipping lane, but the system can send an alert when the ship goes to anomalous track behavior. So it goes out of the shipping lane. And also, there can be a warning if there is, for example, another small ship that is approaching the previous ship, alerting to a potential rendezvous location for a transfer of drugs. This is one example, but then there are others, which also in this use case and the other one. This is an example. Okay, and the last pillar is the interoperability of the project with maritime operational centers, and for example, with the CISE standard, and also with end user legacy system. For the specific use cases that we are dealing with, basically in the project we have two pilots, one which is deals with the drugs smuggling use case, and the other with the irregular migration use case. In any case, the technologies and the capabilities can be applied also to other, let's say, scenarios like goods smuggling, piracy, terrorist attacks, illegal and unreported fishing, maritime accidents, oil spills, etc. That's all from my side. Thank you.
Thank you very much, Ricard, for this brief presentation about the I-SEAMORE project. Now we will jump to Alexander Mackenzie presentation. Alexander Mackenzie, it's one of the end user partners of the I-SEAMORE project. He's from the United Kingdom Border Force. I will share his presentation since he has been having some troubles with the slides. So Alexander, just let me know when I can pass to the next slide.
Yes, good morning all. Can you hear me?
Yes, perfectly.
Perfect. Okay, apologies for the issues as usual from the UK government. Okay, good morning everyone. This is just a little presentation from myself and Gareth Ledbetter from UK Border Force, just to show you the work that we do in the UK and where we are linked in with I-SEAMORE. So, for instance, although we are not part of the EU anymore, unfortunately, we do receive a budget from the UK government. So for I-SEAMORE, the overall budget we see is 7.9 million, but the UK received a budget of approximately 250,000 euros. Next slide, please. So the UK Border Force Maritime, very much like some of the other end users, our main priorities are illegal migration, smuggling of drugs, firearms and other commodities. We also support partners in areas such as national security, so our fellow naval forces and armed forces. We also protect the UK and approaches from fisheries and pollution prevention. And one of our other main roles is search and rescue, especially in the southeast corner for migrant duties. Myself and Gareth have previous experience, and Gareth is a current cutter commander of the vessel type you see in the screen. Okay, next page. Okay, so I-SEAMORE for the UK government and for Border Force, as it says, provides solution and hopefully can address some of the challenges that we face in the European Union and abroad. The Horizon project gives us this opportunity to collaborate with European partners and industry partners and hopefully identify current and future threats to develop solutions jointly to meet both narcotic smuggling, migrant smuggling, and also pollution and fisheries. Thank you. Next screen. Some of the examples of our recent work where I-SEAMORE would fit in perfectly. You can see the screen. We have 378 kilos of cocaine, which was smuggled by a fast boat. The fast boat left the east coast of the UK and went south and into the shipping lanes. It then interacted with a commercial vessel and then returned back with the 378 kilos of cocaine in the forward part of the boat. This vessel was picked up by chance by an aerial asset, but this is a perfect example of if the system can identify some anomalies of fast vessels transiting into the shipping lanes, we would hopefully pick this type of vessel up on I-SEAMORE and be able to either track and deploy assets to find the commodity. Thank you very much. Next screen. This next slide shows again another example of how I-SEAMORE could fit in with our detection systems. We have a small fishing boat with 1.3 tons of cocaine, which again was tracked out into the fishing lanes. It was not doing normal fishing patterns. It was then identified to interact with a larger commercial vessel and return back to the UK. 1.3 tons of cocaine on board, value of £100 million in UK. So it shows the benefit of the I-SEAMORE platform and the AI, which could hopefully track and monitor and identify anomalies for us to intercept. Thank you. Next slide. One of the other I-SEAMORE scenarios is illegal migration. So again, we have a fishing boat here, which is not doing usual tracks, identified coming in from the European continent. On this occasion, 69 illegal migrants on board. So again, if we have I-SEAMORE and the AI systems that could track and identify these anomalies, this would be a great benefit to the UK and all end users throughout the UK, throughout Europe. Okay, next slide. Current Home Office capabilities. We do not have UK-wide drone access. So at the moment, most of our assets are limited and concentrated on the south coast to identify migrants and the at-sea drop-off, which is narcotic smuggling. So as you can see there, we do have some fixed-wing patrol aircraft. We do have some small drones, predominantly by Takiva, but at the moment we are looking to increase our AI and our UAV potential, which links in with our participation in I-SEAMORE. Thank you. Next slide. Okay. Evolving challenges, as I've already mentioned, we are looking for long-range traffic, unusual vessels to meet the narcotic smuggling, which previously was on small boats through sailing vessels, but now we are seeing much more fast craft and fishing boats coming out from the UK. Thank you. Next slide. Okay, I-SEAMORE, as previously mentioned by Rickard, we are looking for I-SEAMORE to improve our border security through the I-SEAMORE ecosystem. We're looking to bring all the intelligence together to analyse the data and identify anomalies. And any anomalies that are identified, we are looking to either put UAVs or fixed-wing aircraft up to assess the threats and challenges. Okay, next slide. Okay, so I'm not going to talk too much about this. We see the partners. We are all very much linked in, and only last week we were over in Troya with our partners to assess the ongoing trials of the system, and as end users we take full part of that. Thank you. Next slide. Okay. Wider benefits. It's already been mentioned, but enhanced border security. From Border Force Maritime, we link in with other end users to get real-world experience of smuggling through narcotics, migrants, and through pollution and fisheries. We have better benefits of illegal migration and better knowledge of smuggling routes and methods. And we also benefit from a focus on fisheries and anti-pollution. Okay, next slide. Okay. As previously mentioned from Rickard and the team, we will be part of the final demonstrations in June and September. We will share our ideas and scenarios with our partners and European colleagues, and hopefully at the end of the feedback, we will have a development of a product that will benefit EU and UK and worldwide security, society, and maritime environment. Thank you very much. Okay, thank you very much for listening. Apologies for the usual IT issues, but that is all from the UK at the moment. Thank you, Laura.
Thank you very much, Alexander, for your presentation. Before starting with the presentations from the other two end user partners, I'm sorry for the mistake, of the I-SEAMORE project, we will like to welcome Marina Andeva from ISIC. She's the ethical manager of I-SEAMORE, and she can bring us another view of these AI technologies and how they work in this type of European project. So, Marina, the floor is yours.
Thank you. Thank you very much. It's a pleasure being with wonderful people and speakers according to the agenda that we all saw, but also numerous participants that can hear, learn, and maybe exchange views on so many benefits of this projects. My role here is a little bit different, so I'm not focusing on the technological aspect, but I am focusing mostly on the ethical and privacy aspect, or ethical and legal management of research projects that concern security and border management. Of course, as also it was previously mentioned, one of the core aspects and issues when projects of such a scale and a topic are concerned is the ethical aspects and the trustworthy artificial intelligence principles of the activities. Specifically, now I'm talking about the project I-SEAMORE. So I will be briefly presenting what we are doing within the project, and maybe when we will have some time for discussion, I will of course be open to discuss with you. As the Artificial Intelligence Act coming into force last year, that was mentioned at the beginning, and previously a couple of years back, the trustworthy AI recommendations and principles that were issued by the European Commission, we as a project focus mostly, and we underline our work and we comply with our work according to the several principles that are established there. So I'm not going to read them all, but just listing them and mentioning that they are recognized, of course, within the recitals of the AI Act, the human agency and oversight, the technical robustness and safety, privacy and data governance, transparency, diversity, non-discrimination and fairness, and the social and environmental well-being and accountability. So apart from this, as a basis of our core work, we have developed a sort of a framework, both in terms of theoretical with principles and procedures to be followed, but also a little bit of practical when it comes to concern of specific assessments and activities that we do within the project. We developed a so-called framework, which we call SELP framework, and that's an abbreviation for social, ethical, legal, and privacy issues, where we provide guidelines along with other with all the consortium and project partners, guidelines on how to manage and comply with the framework that we have developed, and I will explain later briefly a little bit the framework. Within the framework, we've developed and we are conducting self-assessments and risk categorization, and at the end of this processes with the consultations and workshop in order to coordinate our steps. Our SELP framework in I-SEAMORE consists of three main pillars. The first one is how we govern the things within the ethical and legal and data protection aspects, with many governance actors, with bodies that are responsible for the ethical issues, and of course, what is the basis behind all of that, and that is the standards and principles that we follow within the project. Then the procedures, as underlined also in the GDPR, the General Data Protection Regulation. We conduct a data protection impact assessment, but also we're monitoring through the course of the work many activities and the use of the data and how the data are processed. I'm talking about the personal data according to the GDPR. So we do self-assessments, we do also independent assessments, and we involved in this activities all the project partners, including the end users. And the activities and outposts, of course, with the testing and validation. Previously, we contribute to the ethical preparation and requirements that has to be met for this testing and validation. We do the meetings in between to discuss about it, and of course, we organize specifically focused ethics workshops for explaining the requirements of our SELP framework, but also explaining the requirements of the AI, recent AI Act. They are, as I mentioned, so the core division of our work in the SELP framework is divided between principles, guidelines, procedures, governance actions, recruitment, and tools. I've mentioned, and you saw a little bit the governance actors, but I want to focus more on the principles, as we adhere and we have established our own list of principles that needs to be respected within the I-SEAMORE, that are both ethical and privacy principles, but are based on the Horizon regulation for financing instrument, and of course are based on the GDPR and the trustworthy AI principles. And on the basis of that, we produce guidelines and procedures. And when it comes to recruitment, we make sure that all the recruitment criteria and procedures that we establish within the SELP framework are respected when it comes to involvement of human participants. There is a set of tools, checklists, and self-assessments that are needed to. When we concern about specifically AI and the AI components that are developed, that our project coordinator Ricard explained just a while ago, we do a specific AI assessment, and we use the tool produced by the European Commission, which is the LTI acronym tool, an online tool that is divided in terms of the trustworthy principles and a set of questions that are developed that help us and help the project partners, to help the consortium in order to assess each of the components and whether it is in line or not, and what are the recommendations that can be done in order to get to more trustworthy AI components developed within I-SEAMORE. So we follow generally 3 steps. First, we do a risk level categorization, then we conduct the LTI assessment, and a final reporting of result. Just a clarification, risk level categorization, because the AI Act, as it was mentioned before, it's a pretty much risk-based legal document where several risk categories of the AI components and an AI system in general are defined. Another aspect with the risk level categorization in specific is that because it's a new, relatively new now, 1 year will pass, and there are many provisions of the AI Act that are still in the process of the implementation, with a prolonged implementation and entry into force. We do a compliance checker, so we conduct for each of the AI components whether it is a subject of the AI or not, whether it goes within the AI provisions and it should be governed by the AI provisions or not. Then with the partners together, we developed a tool where there is a self-risk categorization in terms of the results of the AI Act compliance checker, and of course of the knowledge that the partners have in technical and institutional and legal knowledge. And we make sure at later stage to see what could be the compliance measures, if there are any significant alert issues that needs to be met. What we do for each categorized AI component, we define compliance measures. This is a continuous process, a continuous monitoring with individual consultations, with group consultations. We also have in I-SEAMORE external experts, ethical experts, data protection experts that we involve in order to make sure that we follow throughout the process correctly. when it comes to the self-assessment of the trustworthy area, apart from the Altai, we have thought for the more friendly use and more elaboration of each component and specific principles. After you have a set of recommendations and you have underwent the Altai assessment. Maybe some questions. Maybe you don't have some space for questions for elaboration and explanation there upon the questions. So we have the really friendly and short self-assessment sheet where for each of the principles an explanation is given according to the requirements. I hope I was in the timeline. I've tried, even though it's always challenging to meet in just a couple of minutes all these important issues and challenging issues. But thank you very much for listening to me, and I'm here on disposal for the whole time of the webinar. Thank you.
Thank you very much, Marina, for your presentation and for being willing to participate in our I-SEAMORE webinar. Now we will jump to José Ramón Cascales' presentation. José Ramón is from the Spanish Tax Agency. I will share your slides, José Ramón. You don't need to worry about that. Just let me know when I can skip to the next slide. And turn on your microphone, please.
Okay, sorry. Good morning, everyone. My name is José Ramón Soto. I belong to the group of technical experts in navigation of the aerial and naval operation area of the Spanish Customs Surveillance. In this presentation, we'll start talking about the Spanish Customs Surveillance and its functions. This is important to know in order to relate then to the role we play as end user of I-SEAMORE. This will be a brief presentation, don't worry. Next one. Okay, the Spanish Customs Surveillance Service is included in the Customs and Excise Department for administration and inspection of taxes on external traffic and excise within the tax agency for application tax and customs system, and all of them under the Ministry of Finance. Next one, please. The Spanish Customs Surveillance is a law enforcement agency with judicial police functions, specialized in the fight against drug trafficking, tobacco smuggling, money laundering, and tax fraud. This one. To carry out our tasks, we have implemented a maritime surveillance system consisting of combining our technical and intelligence support with our aerial and naval resources in an integrated and fully coordinated manner. To this end, we have our own excellent database and the means necessary to carry out our monitoring and intervention on possible targets suspected of committing crimes related to drug trafficking and smuggling. Our Spanish Customs Surveillance has maritime bases at the strategic points throughout the national territory, covering the entire area of our territorial waters. As you can see in the picture, we have three, and in the north, in the Cantabrian Sea, there are 6 bases at Galicia, an important zone or important area because of the vessel traffic from America to the north of Europe. There are 6 bases at Andalusia. It's a hot zone in this moment for drug trafficking and smuggling because of the nearest from Africa. There are only 14 kilometers in the Strait of Gibraltar, and 8 bases at the Mediterranean coast, including Balearic Island. 2 bases in Canary Island. It's an important area too, because there are all the vessels who travel from South America and South Africa have to pass through the Canary Channel to the Mediterranean and the north of Europe. Additionally, we have two offshore patrol vessels for special operations, with which we can intercept suspicious targets at great distances. I remember the last one, it was in December of 24. We intercept a fishing vessel with cocaine 1,200 miles from the Canary Islands. Next one, please. Okay, well, regarding to the goal of this presentation, we look at the role that Spanish customs surveillance play in this project. We are considered end users in this project, so we are trying to carry out three important tasks: creating use cases, validating use cases, and supporting partners. Next one, please. The Spanish surveillance is committed to innovation and the development of AI to incorporate it into its new technological capabilities. In 2025 and coming years, our main challenge is continuing implementing improvements in automation as a preliminary study to be able to generate our own AI. Now we aren't currently using AI because of a huge amount of data is needed, which locally the total number of our intervention and action doesn't provide. Okay, so another challenge is to carry on feeding the real use cases database with anomalous behaviors detected and studied. And the last and most important challenge, we think, is to complete a total digital transition, including the AI as a powerful and useful tool. Next one, please. How can I-SEAMORE address this challenge within achieving better detection, classification, and track monitoring capabilities of possible targets? Next one. This can be accomplished by employing visual analytics tools combined with a novel and comprehensive suite of AI-based function services and big data analysis to achieve optimal decision-making and successful execution of planned missions. Well, to the end, the commitment for 2025 to 2026 is to continue with the implementation of technological improvements, both hardware and software, to make the customs surveillance through the SECOP a more modern and efficient force. And it's in this area where I-SEAMORE has a great projection for us. And this is the end of my presentation. Thank you very much.
Thank you very much, José Ramon, for presenting everything regarding the Spanish Tax Agency and your work within the I-SEAMORE project. Now we will go to the presentation of Valentin Micu. Valentin is from the Romanian Border Police, and he's also one of the main end-user partners of the I-SEAMORE project. Feel free,
Hello.
Valentin, to start presenting.
You can see my presentation?
Yes, we do. It's just still loading.
Switch to presentation mode.
Okay, perfect.
Just tell me when you have it.
Yes, it's good to go.
So my presentation is mainly covering our role within the project, within the I-SEAMORE project. And I will discuss at the end of the presentation, just touch upon the use of AI currently and what we are aiming to do in the future. So we, as the Romanian Border Police, the Coast Guard within the Romanian Border Police, are responsible for the implementation of Task 2.5, which has the main object to develop the set of guidelines and recommendations regarding the policies association to the maritime surveillance. We are, as I told you, we are leading the task together with the other end user and under the coordination of the ISIG. So achievement that we are aiming for is to establish the structured approach to draft the policy guidelines based on the operational experience of the Coast Guard agencies and within the I-SEAMORE project. And we structured our document in mainly 9 defined areas. As you can see, the technical integration, the interagency cooperation, the legal frameworks, the community and stakeholder engagement, implementation guidelines, sustainability standardization, the capacity building, and the technological evolution. So regarding the challenges that we are taking into consideration is the heterogeneity of the legal frameworks of the partners, the limited interoperability between existing systems, and also the variability in stakeholders' engagement and also the commitment at institutional levels. And other challenges is the difficulty in consolidating lessons learned based on the actionable policy proposals, and balancing innovation also with the regulatory compliance, and also ensuring long-term sustainability for proposed measures. So for now, we just developed a drafting document for the tasks, for this task, and we also, under the coordination and advice from ISIG, we developed also a set of questions, a questionnaire based on the draft that we developed, and we are going to circulate among the end users and also the partners in the project in order to define the final version of the document to be finalized. So as I said, we have just finished the questionnaire. We consulted with ISIG regarding on this, and it will be shared in the next few days, I'm thinking. And after that, we'll have, of course, some online meetings together with the partners to clear out some of the questions regarding this document. Pretty much this is about the role. Regarding the AI in the border management in border management activities, for now we are just currently undergoing the upgrade of our maritime surveillance system. And it includes also this modernization is one of the main component of the upgrade is to provide the software application that will manage the information from the sensors like radars, cameras, and other and the information from the integration with other surveillance applications available here from the agencies from within the European Commission. And also, as I said, one of the main components of this software application is to have AI mechanisms and tools to analyze the data regarding the naval traffic and to provide alarms to the operator whenever based on some defined criteria taken into consideration by the software. Also, we have different information that is taken into consideration from the missions performed by UAVs, mainly provided by the Frontex agency. Now we are on pause with these activities because of the conflict in the northwestern part of the Black Sea, and we are facing with constant, on daily basis, jamming and spoofing of the AIS signal and GPS signal, which make it very difficult for the UAVs. But yeah, this is the activities for now on at the Coast Guard level. Pretty much this is my presentation. Hopefully, I'm waiting for any questions that you may have. after the presentation.
Thank you very much, Valentin, for your presentation. I'm sure someone will have some questions regarding Romanian Border Police work and your tasks within the I-SEAMORE project. Now we will jump back again to the BAG-Intel presentation with Giorgio Bardes. In BAG-Intel, Giorgio leads the technical coordination of all components, working towards the development of a unified real-time platform. So the core concept of BAG-Intel was designed by Legend Technologies and is being implemented by net company Intrasoft, where Giorgio Bardes is a senior software engineer.
Thank you very much. And first of all, sorry for earlier, because the moment I pressed share, Zoom froze totally. I don't know what happened.
No worries.
Okay, so good morning from my side too. I'm George Bardas from net company Intrasoft, and will be presenting BAG-Intel solution, which is another project of this webinar. So what is all about BAG-Intel? BAG-Intel actually is an AI-powered solution, as you can see here, that aims at transforming customs operations at international airports. Let's jump into the solution concept, and to go there, let's first of all visit what are the drawbacks and what are the insights of the customs processes operations at the airports right now. So what you can see here, signified with this airplane, is actually a flight arriving at the airport. When the flight arrives at the airport, of course, we have a lot of bugs with this flight, accompanied with this flight that will go through a dog sniffer, of course, to track if there's anything suspicious inside, like narcotics, like gas and other stuff. They'll go through a conveyor belt to the baggage carousel where the passenger can actually collect them. And then this passenger will have to go through the selection areas and the two doors that you usually notice at the airports, the red one and the green one, depending on if you have to declare or not something. So the problem right now is, first of all, the fact that the processes, the custom processes, the custom operations are totally relied on human judgment. So the current customs control process relies heavily on the subjective experience of these officers, which can lead, of course, to inconsistencies and errors, specifically when there's high traffic in flights. Apart from that, the smugglers have begun to be very skilled and they can mimic the old behavior of a regular traveler. So it puts some more effort to understand if something suspicious is happening there. Of course, the dogs are very effective, but we have the problem that even if the dog suspects a specific bug, then we cannot remove this bug from the carousel and take it because, of course, the smuggler will be alerted that something is not going well. So you understand that if you're waiting, the smuggler waits for its bug and the bug does not arrive, he will be alerted that something is not going well, and he will leave the airport. So the main idea is to try to create a method, a system, a concept that will actually help the customs, help the airport officers and the staff to offload some work, especially when there's too much traffic, too many passengers going through and too many bugs, and not replace them. That's the whole idea of BAG-Intel. To do so, we have introduced some sensors in the processes, including an AI-enhanced X-ray CT scanner that all the baggage will have to go through for automatic risk assessment of the baggage unloaded from the incoming international flights. We have actually introduced an AI vision-based tracking by installing different cameras around, first of all, the scanner and then the other rooms that we are looking at identifying those baggages, and a system web app that is alerting and notifying the customs officers when a bug is flagged and is suspicious, is identified as suspicious, and should be manually inspected by the customs. This is an overview of the whole system. In the orange boxes, you can see the different components that are being deployed through the pipeline of the baggage collection process. So first of all, you can see that on top of all of these processes, there's a digital twin, which is used for modeling and simulating the whole process of the baggage collection. First of all, we have an AI-based analysis of external data and knowledge. These kind of data are the usual data that the customs control officers utilize to actually identify some suspicious bugs. So we are talking about external data from other airports or intelligence that we utilize on this process. We use AI to process this kind of data and make them structured for our system. We have a luggage risk assessment component, which takes all of the different signals we have and calculates if a generic global risk indicator, which says if we need to manually inspect or not this specific bug. We have the visualization of real-time decision support, which is the one that alerts the customs officers that there is some kind of suspicious bug over there and they need to manually inspect it. We have the AI-based detection and recognition of contraband, which is embedded on the X-ray scanner. So in this X-ray scanner, there's an embedded algorithm, AI-based algorithm that detects if there is some kind of contraband, like we said before, narcotics, gas, or other stuff. And then we have the AI-powered image analysis tool for characterization and identification of luggage selected for inspection. So we have a tool that is actually created to re-identify the bugs. So a bug that is initially passed through the conveyor belt when it is offloaded at the conveyor belt here, we use these cameras placed around the XCT scanner to create, as we said, a digital signature of this specific bug, which is processed, which is calculated from the different images we have captured from this specific bug. So this is why we use many different cameras to capture all the different angles and aspects of this specific bug to create this digital signature. So after we have this digital signature, this is combined together with the X-ray CT scanner image and the records with the external knowledge we have about this specific bug, creating an initial record in our database that will be later utilized to identify if there is some kind of contraband inside this specific bug. And later we go to the carousel area through the conveyor belt, where more cameras are installed, and we do the re-identification process, as we call it, where again, through the cameras, we can re-identify if the bug we have in our database and it's considered suspicious is the one that we actually see now in the carousel area and in the selection area at the customs doors. So after we re-identify at the customs doors and the carousel area, we can, of course, alarm the customs officers that the specific bug that have been suspected about having narcotics, for example, it's there, it's this one. The customs can visualize, can see the actual bug, how it is at the conveyor belt, and they can go and manually inspect, arrest the passenger and manually inspect the bug, of course. So regarding the multi-sensor based luggage risk assessment, as I've already described, we use 4 different risk indicators: the external data, the X-ray scanner, the custom control officer's opinion, because the customs control officer's opinion sits on top of all of those. So it's the one that is that has the increased weight, let's say, the biggest weight, because his opinion actually counts more than all our systems. And the dog handler input, which will be if the dog has barked, if the dog has found any kind of suspicion about any contraband. And of course, all of those gather in a total luggage risk that is used to signify or not the customs. Furthermore, this is the visualization of the customs control officers. They will have an indication on what kind of contraband we detected. They will get an indication of many images from the XCT scanner, from the cameras, surveillance cameras of the airport, and all of those. And of course, the global risk indicator, deciding if he should actually manually inspect or not this specific bag. Now, regarding how this project advances the state of the art, I would say that the security scanning of the outgoing luggage is well developed, but the customs scanning of incoming luggage is not developed to its full potential. So this is what we're trying to do here. We have some new solutions that have been gone through the last years about some airports apply radio frequency indication, RFID, as we call them, tagging for the customs identification of luggage. But the problem is that these specific measures usually are described as problematic because they are intrusive ways of applying these measures, when we are trying to introduce a non-intrusive way, so that the smuggler cannot find this tag and not remove it. This is our main problem here. Again, the advancements of bug intel regarding the implementation. Of course, we are using AI-powered functionality for enhanced detection of the contraband in X-ray scanning of luggage. The risk assessment part is AI-powered again, regarding all the external information we get from the external sources like the passenger name record, the law enforcement agencies and such stuff. Of course, we have the re-identification process, which is again AI-powered and based. And the digital twin, of course, for system visualization and performance optimization. All of these will lead to greater effectiveness and efficiency of the customs control processes. Finally, these are our three pilots, our three deployment scenarios in Bug Intel. We have chosen these different three airports based on their traffic. So Billund Airport is considered as a small airport in Denmark. Thessaloniki Airport in Greece is considered like a middle one, an average one. And we have the Madrid Barajas Airport in Spain, which is a big airport with high risk. It's stress testing in high risk and mobile operations with the border police there. That's all from my side. I would say that the next slides I have in this presentation are more technically based, and we don't have the time, I believe, for these ones for now.
Thank you very much, Georgios, for your presentation. We will jump now to the METEOR project presentation. It will be done by I-SEAMORE. I-SEAMORE is an electronic engineer and the CEO and co-founder of METEOR Technologies. I-SEAMORE has more than 15 years of experience in the development of innovative technologies for detection in many fields, such as security, defense, and customs, with extraordinary results in the detection of illicit substances in containers. So the technical concept of METEOR was developed by METEOR Technologies, and it was supported by 4 EU customs authorities. So I-SEAMORE and his team at METEOR are the technical coordinators of the METEOR project and the developers of the METEOR detector. So Luis, the floor is yours to present us a little bit more about this detector and your technology.
Thank you. Here's the presentation. Can you see the presentation, Laura?
Yes, perfectly.
Hello, I am I-SEAMORE. I am the director of the company METEOR Technologies. And today I'm going to present the METEOR project and see how this project is aligned with the concept of I-SEAMORE project. METEOR project, as Laura indicated, is based on the development of a new detector for container screening. The METEOR project the METEOR objective is to develop a new concept of vapor cargo screening. The detector is based on vapor detection with the idea of develop a system faster, more reliable, non-intrusive, and cheaper than the current existing technologies. And we have adapted the list of threats to the real needs of the customs. In this project, there are 4 European customs organizations, and after an interview with them, we identify the main threats in Europe, mainly explosives, drugs, tobacco, and also new psychoactive substances. In the project, there are 12 partners. Vito is the coordinator, and there are different partners from the technical development, and also the 4 European customs, including Belgian customs, Dutch customs, Spanish customs, and Irish customs. And also we have the support of Guardia Civil, which is the Spanish border police. Also in the project is Smith Detection as future exploiter of the technology. The METEOR project was funded under the topic Border Management 0103 in 2022. It has a duration of 3 years, and MEON is the main technology developer, so the solution. When we prepared the proposal, we did a deep analysis of the current screening technologies for containers. The main one, or the most used one at this moment, is X-rays, which is useful in some cases, but which is totally useless in other cases. We can see here a picture from the Spanish customs. This is a container full of metal jar. So in this case, it's not possible to differentiate if in these yellow circles there is something suspicious. No, there was a suspicious of cocaine, but it is not possible to confirm. And even more important, for customs, it's not possible to open this container because all these metals are put in a complex way. It is pressed inside. If they open the container, all the metals go out. The customs don't have the capacity to put it again inside. So for some scenarios, X-rays are not useful, and the detection by vapor detection is essential. I said here this example, but there are many examples with homogeneous cargo or complex cargo. Another technology, not technology, but another solution for inspection of container is dogs. But dogs has a limited sensitivity. We can see here a graph with different threats interesting for customs, including nicotine for the detection of tobacco, TNT, like a standard explosive, and cocaine, hydrochloric or cocaine freebase. In the dark bars are the vapor pressure, the official vapor pressure of one of the substances, and in the pale blue, there is the real vapor pressure inside the container, because the narcos and the terrorists don't put the cocaine open in the middle of the container. They grab many times, and typically the vapor pressure is reduced by a factor of 100,000. So in order, if you want to detect cocaine, you need to reach at the level of parts per quadrillion. This is one of the main innovations of the METEOR project. We are able to detect in the gas phase at the level of parts per quadrillion, which is mandatory if you want to detect cocaine by the molecule of cocaine inside of one container. So after the analysis with the customs, the main needs are they are looking for solutions without the need for opening the container. This is related with the non-intrusive capacity. You don't need to open the container to keep the privacy of the cargo. The results should be automatic. In the X-rays, you need to interpret what is inside. Important, very low false alarm, because false alarm generate a lot of big cost because you need a secondary screening process, typically manual screening, which is expensive, dangerous, you need space, this is very expensive. High sensitivity, we need to detect at the level of parts per quadrillion if you want to detect something. High throughput, and a wide and open threat database, explosive, drugs, tobacco, etc. And the only technology, in my opinion, that can meet all these requirements is vapor detection. For the METEOR project, the main threat is cocaine detection, but we are also working with explosives and tobacco. All the examples I am going to present are focused mainly on cocaine. The concept is very simple. We extract the air from the container, we trap percentage of vapors in a filter, and then we will analyze the filter. The results are automatic, just some numbers. The sampling time is 3 minutes, and the analysis time is around 3 minutes. The sampling process and the analysis process is separate in time and in place, which provides a high versatility of the process. In terms of detection technology, we use our DMA. This is multi-detector DMA technology. This explanation is for 2 hours presentation, so I'm not going to go into the details, technical details, but if any of you have any question, I will be more than happy to present you how we reach these levels of detection. And in the project, the step number 1 is the understanding of the vapor behavior in one container. For this, we have the collaboration of different centers, research centers like Vito and TNO in the Netherlands. We are testing real samples of cocaine, in this case in simulated environments, under control parameters in temperature and humidity. And we are trying to understand what happened with the threats under normal conditions, because in the lab, everything, as you probably know, most of you know, in the lab, everything is easy, but when you go to real life, from TRL5 to TRL8, there are many, many things to solve. For example, we have been working on the analysis of the containers for many years. One of the limitations is containers are dirty, contains a lot of dust, a lot of things. So this is a problem that we have already solved. This is just one example. The second step is perhaps the most attractive of this project is the quantification of concentrations, vapor concentrations from real transportation of cocaine. For this, we have a very good and active collaboration of the customs, mainly Spanish, Dutch, and Belgian customs. They are providing us the opportunity to analyze, to take samples from hot containers, suspicious containers. Up to now in the project, we have screened more than 300 background containers and more than 75 hot containers. Hot means that the risk management system alert the container. And what we do is to analyze these hot containers and to confirm the presence of cocaine according to our results. So in this picture, you can see our sampling unit. This is a portable system that we extract the air, and then the customs send the samples to our lab for the analysis. For example, we have achieved important detections in this project. This is in this picture, you can see a container with zeolites. Zeolite is a chemical absorbent coming from, in this case, from Latin America. There were 2 containers with this cargo. Both contains cocaine, and it was detected by our system. The second one was a big, the result generate a big investigation, police investigation with some people arrested. And for example, the transportation of cocaine mixed with another chemical product like zeolite in this case is not possible to detect by X-rays, of course, because this is an homogeneous cargo, an homogeneous mix, and neither for dogs, because the limit of detection is very slow, very low. We detect at the level of 30, 40 parts per quadrillion. So there are some pieces of news in Spanish newspapers speaking about this detection. And we did some other detections, containers with corn, calcium carbonate, ginger, bananas, plastic bars, nuts, etc. We have achieved many detection, but this is, we support the customs in the screening of the container, but what it is important for the project is that we now know the level of concentration of vapors of cocaine inside of one container in the real scenario, not in a simulated scenario. These are containers coming from, I don't know where, and it contains cocaine in packages mixed with other things, with coffee, with many things, and it is the real life. And the step number 3 is the development of the METEOR project. This has been done in parallel with all these activities of in the field. The technology is based in our DMA. This give you can see one idea of the DMA. If you have curiosity, I can explain. We are developing a new chip. It is a sensor with ultra-low noise in the collaboration with the Institute of Microelectronics in Barcelona. This is a very good development activity. At this moment, the detector is under integration in the lab, and we have included the detection of cocaine, tobacco, and explosives. For next year, there will be the final validation in real case in different ports in Europe. And that's all.
Thank you very much, Luis, for this insightful presentation about the METEOR project. To wrap up all of the presentations of today, we will have Nicholas Palagias. He's the CEO and founder of Codable, one of the core technology partners of the ODYSSEUS project. Nicholas brings a strong background in software engineering and behavioral analytics, with previous experience as a PhD researcher at the Institute for Communication Systems, home of the 5G Innovation Center at the University of Surrey. In ODYSSEUS, Codable is responsible for the development of a continuous behavioral verification, which verifies the legitimacy of a mobile device user based on how they interact with their phone, such as typing, swiping, holding, moving with the device. This solution aims to provide stronger identity verification compared to traditional single-use passwords, while ensuring a seamless, uninterrupted border crossing experience. Nicholas, the floor is yours. Feel free to share your presentation.
Thank you very much, Laura, for the intro and for the invitation. Very nice to meet you all. So I'm Nicholas Palagias. I represent Codable. We're a cybersecurity SME with entities in the UK and in Greece. Our primary focus is on basically helping organizations reducing fraud and improving their user experience. And how we do this, we do it primarily through combining cybersecurity and behavioral analysis, and all of these are fused through artificial intelligence. Today, I will speak a bit about primarily the use case of the border crossing, the seamless identity verification at land and water borders. And this is related to the ODYSSEUS project. So let's have a quick look on the different challenges that are faced at the EU border crossing points. So, of course, the primary issue that is faced on the different border crossing points is the increased traffic and queues that are observed primarily at the external borders of the EU, as well as in between Schengen and non-Schengen border crossing points. So this has led the primary reason for this is, of course, the need for increased manual inspection by the border authorities. And all of this, of course, leads to significant queues, of course, travelers' frustration, but also this has an economic impact, considering that different goods are transferred across different countries. In terms of the current identity verification process, this is done primarily as a manual procedure by the border authorities, where an identity document is scanned and verified against the traveler. In cases of third country nationals, here we can see that there's an additional requirement about providing explicit travel documents and, of course, the fingerprint sampling scanning. In terms of some automated tools that are currently used by the border authorities are the different document scanners that are scanning the machine readable zone that you can see here in the picture of the passport, and also the e-gates that you primarily observe at the airport border crossing scenarios. Now, in terms of the ODYSSEUS platform and approach, this is a quite novel platform that is focused on enabling seamless identity verification and in general border crossing for EU citizens across Europe across the external borders of Europe, but also between Schengen and non-Schengen countries. How this is done is primarily through advanced multimodal technologies that are focused on verifying the traveler's identity, on performing screening of the vehicles that are used by the travelers to cross the borders. And all of these are combined into an overall risk score that is provided to the border authorities to make the final assessment regarding the particular traveler. So this is assisted by a decision support system that explains basically the results of the overall system, and it's focused, as I mentioned, at the land border, including the train scenarios where there are stationary BCPs, and the water scenario where we're referring primarily to ports, border crossing points. In terms of the consortium, as you can see, we have five reputable end user bodies, including the International Association of Railways. It's two large companies in the identity verification and in the vehicle screening. 6 SMEs and 1 research institute that assist us with the legal and ethical parts of the project. In terms of the technological advancements and components that are offered by the ODYSSEUS platform, first of all, we have the seamless identity verification in border crossing scenarios that allows the identity verification of a person without without the human involvement. Then we have the digital and virtual passport, which I will speak a bit more in a bit. The AI-powered continuous behavioral authentication mechanism to secure the digital and virtual passport. We have some X-ray technologies that enables the vehicles to cross the border without stopping, and this is quite a novel element, considering that the travelers do not have to exit the vehicle in order to perform the scanning. We have some UAV technologies focusing on thermal and high-resolution cameras that allow a pre-screening of the travelers. A GDPR-compliant travelers counting component that informs basically the border authorities about an increase of an increased number of travelers approaching the borders. And then finally, all of these are fused through the multimodal fusion and decision support component, which, as I mentioned, is equipped with explainable AI to enhance, let's say, the privacy and the trust of the overall system. The solution is already being piloted, and we're currently doing the first round of pilots across land, water, and train scenarios. So now we have completed the initial phase of the pilots, and we are planning to perform the second round of pilots, incorporating the different types of improvements. Here, I will not detail the scenarios, but yeah, the overall concept is that we have an initial pre-screening of the travelers in the vehicle, and then we have the fusion of the identity verification and the screening of the vehicle at the border crossing point. Now, in terms of the identity verification, and in particular to the digital wallet, a technology that is introduced by our colleagues from Thales. This is based on the digital travel credential, following the standard of ICAO 9303. This is a technology that enables the travelers to convert their physical identity document into the digital travel credential, meaning they can insert their passport basically into their smartphone in a secure and standardized manner. So this is one of the technologies that is being developed through the ODYSSEUS project and allows the travelers to cross the border using their smartphone. In order to basically increase the security of the particular mobile wallet app and the digital wallet app, a novel technology focused on AI-powered behavioral authentication is being developed through the project. In essence, what the specific technology does is that it analyzes different types of patterns of the user while interacting with a digital wallet, such as the way a person is holding the smartphone, how they type, how they swipe on the phone, the pressure that they apply on the screen, the surface that they touch on the screen, and all of these are combined with the biometric elements in order to provide a risk score of the person that is using the specific digital travel credential. So the system continuously learns the behavior of the user while the person is interacting with a digital wallet. So it doesn't monitor, let's say, or process information outside from the digital wallet. And this is quite important to point out. And while the person is interacting with a digital wallet, a risk score is generated, and this is provided to the overall ODYSSEUS platform. Of course, we apply different types of data anonymization mechanisms on the device in order to, let's say, ensure the security and the privacy of the travelers. And just to mention that the travelers at any point, initially the travelers provide the consent for this type of processing and data collection to take place. And at any point of time, they're able to withdraw this consent and delete any data or knowledge extracted about them. Here you can see the different attributes that we're using. So we look into the location patterns, the distance, and the speed that the person is moving. We incorporate the facial recognition component, and then we have elements such as I mentioned, how the person swipes, the different gestures that they perform, the typing behavior, how they hold the device. And all of these are combined in order to provide a verification score. Let's have a look on two examples to showcase a bit the actual use case. So this is from an assessment that we performed internally at Quadamul. So we deployed the solution to certain devices, and this is one case where a further analysis was performed. As you can see in the specific case, we have an increased confidence that the fingerprint of the fingerprint from the sensor of the device was performed that this was the correct user. However, the rest of the behavioral patterns provide a low score regarding the authenticity of the user. So in this way, the overall system provided, as you can see, a high confidence that this is not the correct user that is accessing the app. And probably what has happened in this case is that the fingerprint sensor of the device has been compromised. Now, a second scenario. Here you can see that the overall risk score of the system is reassuring that it's the actual person that is using the device. Even though the location and the interaction patterns identified by the system are low, so the confidence is low, meaning that this is not the correct person. The rest of the behavioral patterns and biometrics were able to compensate about this and provide an estimate correctly that the legitimate user was accessing the digital wallet app. So now, basically, what happened in this case was that the particular person had not been before to the specific location, and for that reason, the system, the specific behavioral pattern provided a low confidence. We have prepared a video, but I'm not sure if it's gonna, if we have time to show it. So yeah,
You still have 1 minute, so if you want to try to show the video, if it's less than 1 minute, it will be good.
It's around 1.5 minutes, so yeah, I can try.
I think we are okay. Unfortunately, there's no sound. Nicholas, would you be able to turn on the sound?
Now I can try again once more if it doesn't work. Is there sound now?
No, we cannot hear anything, unfortunately.
User onboarding and data
Yes,
collection.
now we can.
The process begins when a legitimate user registers with a digital wallet and starts using the app. As the traveler uses the app, the behavior verification SDK, which is integrated with a digital wallet, continuously collects data. This includes device interaction patterns like swiping and scrolling, movement behaviors, and typing characteristics, such as key press timing. Machine learning models analyze this data to understand the unique behavioral patterns of the legitimate user. During verification, the decision support system updates the status of the digital wallet, determining whether the user is legit or an imposter. Here, the traveler is correctly identified as a legit user. Now, an imposter attempts to access the digital wallet following the same process. Even if they have obtained the legitimate user's password, the behavior verification system detects anomalies in their interaction with the phone, such as different swiping, scrolling, or typing patterns, which do not match those of the legit user. Returning back to the decision support system, we can now see that the behavioral status has been updated, correctly identifying the imposter and preventing unauthorized access.
Thank you very much, Nicholas, for your presentation and for this insightful demonstration. It was very nice to see. And now we can go to the Q&A part and have a little bit of discussion with all of the participation projects and the speakers. I will just open here the chat very quickly. I know that we have a couple of minutes for the questions, and we already have two in here. So the first question goes to the I-SEAMORE project. Maybe Ricard, you can be the one speaking on I-SEAMORE behalf. So is I-SEAMORE tracking boats and checks their patterns, comparing them to usual known patterns?
Okay, with regard, basically, there are several, let's say, cases where it is based on the assessment of the end users, where there's some suspicious activities may happen. So, for example, last week we were in Troya making some tests of the system, and the UK Border Force came with an example of a specific cases that happen in, let's say, in the nearby UK, where some fishing boats. Instead of the example I showed before, that the main commercial vessel, let's say, deviates from the main shipping lane. There's a case that the main commercial boat, let's say, sends or put some parcels on the sea, and then the fishing boat comes and they say searches for the parcels in the route where it's agreed that it should be, let's say, dropped. So this is another example. So basically, we are, let's say, implementing the cases that are known by the end users, and we try to, say, to implement this on the irregular or suspicious behaviors, no? So this is one of the examples, but they may be others, no? So basically, we try to, based on the knowledge from the users, to trap this information and then to make the system detect this let's say not usual behaviors, no? Of course, we have some of them that, like, for example, the rendezvous, when two ships approach to the same point, one deviating from the shipping lane and the other, which is maybe probably a smaller one, no? So it depends on the experience and the, let's say, evolution of the of the smugglers, no?
Yes, Georges, feel free to speak.
Okay, thank you. First of all, thank you for your answer. So actually, you do not compare to some patterns, real data patterns you have, let's say, in some database. You just compare from the end users part. So the end users identify that this specific fishing boat pattern is not the usual one. So there's something suspicious there.
Ricard, could I
Yeah, of course,
come in?
of course.
Yes,
Yeah,
please.
so obviously I'm from UKBF, I'm Gareth. So we started by putting in specific scenarios from our experience, but the understanding is that actually the system will learn and it will establish pattern of life, and from that it will then be able to generate anomaly reports for anything that deviates from what's perceived to be the norm. So if it works in the way that we're hoping it's going to work, every time a new smuggling technique occurs, the system should identify something about the behavior of one or both of the vessels that is anomalous and generate a report. Is that your understanding, Ricard?
Yeah. Basically, the system, there's two type of alerts, let's say. One, which is the risk, which is understand when something known is happening, and the other is a kind of an alert when something, let's say, is suspicious, but is not by definition some of the known behaviors, no, that are probably taking some place when some smugglers try to transfer drugs from one ship to another, no? In many different ways, no? So basically, because when you see an ACE map, a map with all the ships with the ACE activated, it's crazy. So it's not possible for a human being to track everything, all the behaviors, no? So basically, this is a way of selecting which ones are suspicious, and then probably tracking the routes, etc. But the system is able nowadays, based on the assessment from the end users to detect some, let's say, very high potential smuggling cases. No.
Okay, thank you very much.
Thank you.
Thank you to the three of you for answering this question and making this participation on the Q&A more dynamic. We have another one that I believe it's for the Back Intel project. So did you develop the AI detection tools on the X-ray CT on the contraband within the project? And if so, which contrabands?
Yes, actually, the tool from the AI tool for the X-ray CT scanner is provided by Spetsdetection. So it is an embedded application on the X-ray CT scanner, and it only needs to be trained by the data. So it is trained to each specific scenario. So in Bug Intel, Spetsdetection trains their tool with data that have been provided from the end users, so from customs. And specifically, they have trained with contraband like gas, pills. I believe that Michael from Smith has already responded. They have trained with pills, cigarettes, gas, and some narcotics like heroin with different purities and such stuff.
Yes, at least this is the plan. We are working on it.
Thank you very much. I don't think we have any more questions here in the chat. I don't know if anyone else would like to drop by any question or would like to open your mic to inquiry one of the speakers.
Hi, good morning. It's Alex here from Border Force. Just to add on to what Gareth was saying and Rickard, it was our understanding that with the meeting and the trials we had last week in Troya, speaking to the system providers, the system is already identifying usual known shipping patterns and movements in the Troya-Lisbon area. And hopefully with the June and September tests, it is learning these patterns and behaviour. And what we were looking for in Border Force in the UK was identifying unusual movements within those known and agreed shipping patterns. So this is, as Gareth and Rickard was saying, one of the main benefits of identifying unusual and anomalous behaviour in the relevant areas. We understand that the UK has a particular shipping area and characteristics that may be different to Spain or Romania, but it would be hopeful that the AI system and the I-SEAMORE system could learn that what is usual to each particular area and then identify what's unusual. So that's just another point to add from the UK. Thanks.
Thank you very much, Alexander, for adding this information to the discussion. I see that we don't have any more questions in the chat. Either way, the full recording of this webinar will be available on our YouTube channel, on I-SEAMORE YouTube channel. So everyone can review the presentations. You can share with your own network and with the interested people on these AI topics. And we are right on time to end this webinar. Thank you, everyone. Thank you for the participating projects, to METEOR, ODYSSEUS, Bug Intel, to all I-SEAMORE speakers, and also thank you to Giulio Mancini from DG Home for participating in this I-SEAMORE webinar on AI operations and border management. Don't forget to also take a look on our previous webinar where we presented a little bit more about AI technologies in each of these projects, where we also have a presentation from the FlexiCross project. It is also available on I-SEAMORE YouTube channel. And that's it. Thank you everyone for joining, for attending, and we hope to see you soon. And have an happy Easter, everyone.
Thank you. Bye-bye.
Thank you all. Bye-bye.
Thank you.
Bye. Thank you very
Bye,
much.
everyone.
Likewise.